Namaste to everyone. I welcome you all in my YouTube video channel. Now, I will give the idea of relations with examples of real life. When we speak about the term relation, we think about two persons, relation between two persons, or two things. First thing is heavier than second thing, or two numbers, first number is less than second number, and in this way we get the relation between two persons or two things or two numbers or between any two. Let A is father of B, or A is heavier than B, or number A is less than B. In each cases, here we get relation between A and B. If we denote relation by R, we may write A is related to B. We may also write this as ordered pair. This is an ordered pair. Why we use the term ordered pair, not pair? Because here we see that if A is related to B by the relation father, that means A is father of B, and if we write BA, then B will be the father of A, which is not correct according to our assumption. Here we have assumed that A is father of B. So we write this ordered pair, not this ordered pair. So we always use the term ordered pair for this relation. The element in the form of ordered pair must be an element of the Cartesian product of two non-empty sets. So, if A and B be two non-empty sets, then ordered pair AB belongs to A cross B, Cartesian product of A and B. Again, if C is father of D, then the relation between C and D is denoted by ordered pair CD. In this way, if we collect all such type of ordered pair and make a set, and that set may be denoted by R, and R contains ordered pair AB, ordered pair CD, and so on. Here, in each ordered pair, we see that first component of ordered pair is father of second component of the ordered pair. Here A is father of B, C is father of D, and in this way we get this set, and this set R must be subset of A cross B. Therefore, a relation R from a non-empty set A to a non-empty set B is a subset of Cartesian product of two sets A and B. Here the sets A and B may be different or identical. When the sets A and B are identical, then we say that the relation defined on set A, that is R is the subset of A cross A, means Cartesian product of A and A. Therefore, a relation R from a non-empty set A to a non-empty set B is a subset of Cartesian product of sets A and B. Therefore, we may define that each subset of the Cartesian product A cross B is a relation from a non-empty set A to a non-empty set B. That is, number of subsets of Cartesian product A cross B be the number of relations from non-empty set A to non-empty set B. Let number of elements in set A equal to M, number of elements in set B equal to N, then we know number of elements of Cartesian product A and B equal to A multiply N, that is Mn. And number of subsets of Cartesian product A cross B equal to 2 to the power number of elements in A cross B, that is 2 to the power number of element in A cross B is Mn. Since each subset of A cross B is a relation from A to B, therefore number of relations from A to B equal to 2 to the power Mn. In the next lecture, I will describe about the types of relation, equivalence relation, partition of a set into disjoint equivalence classes with the help of examples of a real life. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.